Hello and welcome to the second webinar of Louis Bellet. First of all, let me introduce myself for the ones who don't know me. My name is Hervé Baour and I'm handling global marketing and international sales for Louis Bellet. After this, the first session that you can find on YouTube our YouTube channel, and which was dedicated to our so-called 1620F super finishing and mill. I'm pleased to welcome you here again. This session will cover our high performance 353 drill series titanium. Before to talk about today's drill, let me inform you that in Switzerland, we are curious. And as we are curious, we would like to know in what type of industry you are working in. And I will directly open the first survey or first poll, asking you from which industry you do work in. So I'll leave you some time to do this. So let me talk about our today's star. It's the free flutes drill. So it's the 353 series, 353 series. This drill is performing extremely well in titanium. So this tool has been developed many years ago, and its performances has been proved many times in different domains, as various as watch industry, aerospace, medical, among many others. Directly into the material, and thanks to its free flutes, this tool is not only a drill, but it acts as a drill reamer, making the holes really perfect in many aspects, as we will see it afterwards. To go more into detail and to talk more about the geometry, let me give you some more information about it. So it has a tip angle of 140 degrees. It has a helix angle of 34 degrees, a standard tolerance of 2 microns on the diameters, and the diameter from 0.1 up to 14 millimeter from stock. This tool has various cutting lengths depending on what type of tool you do choose. We do have a 353 series, the generic series, but we have the -0, -1, and -2. Some time ago or recently, let's say, we acquired here at Louis Bellet a new simulation software. This simulation software allows us to use finite elements and define how a geometry acts in different materials. So as I said, this tool was developed some time ago already, but we wanted to be sure that the geometry was optimal. So we did the simulation, and as you can see on the animation, the chip has the heat which is generated and evenly distributed or diffused. So you see that the chip is greenish bluish, which represent a low temperature, and the higher it comes, the red it comes as well. Before the chip is rolling out, the radius is fairly small, so it will break pretty quickly, and it will force the chip to fragment before it rises all along the flute. So that's what we wanted to do, make small chips and really not overheating the complete thing. As previously mentioned, this 353 series drill has proven in many customers over the last years. Not only in small diameters, it also really works well in bigger diameters, reaching over 14 millimeters in terms of custom tools. So we might also go higher in diameter. In order to show how this tool is working, we did a small video and we tested this tool 353-1 with a diameter of 3 millimeters in titanium grade 5. It was tested on our Vilma Macodel machine, the 401S. and the tool was uncoated. We didn't do any centering or point drill nor pre-drill. We directly went into the material. The cutting speed was set at 40 meters per minute with a feed rate of 0.47 micron per turn. The speed was at 4,200 RPM. So you see the tool, and as said, there were no pre-drill or center drill. We directly went into the titanium. You can also see that we do a deburring. We recommend to make each quarter of the diameter. So in our case, every 0.75 millimeter. All this with oil-based lubrication. Each process and machine are different, and you definitely can also point drill in order to do this operation. And we would recommend 120 degrees centering. But in many cases, our customer has a 90 degrees tip point, which also works well. So you have multiple choice depending on the machine you are using or the process you are completely have in your hands. Now I can show you the different measurement we did based on the holes we made on our plates. But we also did some trials with different other cutters. So on the first column, you see the result for the 353-1, the 3 millimeter diameter that we used for as on the video. We also did test our standard Louis Bellet tool with 2 flutes and a dedicated competition drill dedicated for titanium. And we see here various measurements. From the burr side, you have the burr when you do enter into the material and when you do go out. With this, you have various results, taking into consideration our tool, the 353, the 3 flutes drill. It goes from 4 micron on the top up to 15 microns because, as you know, when you go out of the plates, you have more burr between 4 and 15 micron, which is really well. Our standard tool works pretty good, so said, reaching 300s or 1200s from the top and the bottom burr. And the competition is also 10 times or even more bigger with the burrs reaching 40 microns on the top and 90 microns on the bottom. On the localization, so means the place the hole should be, all 3 tools are doing great, between 4 and 5 microns precision in positioning. So it's really good. And on the roundness, we go between 3 and 4 micron with our tools and 8 microns with the competition. And if we do a small focus on the circularity, on the roundness of these holes, you do see here the 3 holes with the measurement on the left diagram. You see the imprecision of the roundness of the hole. So if we take our reference 353, you see that we have a mean value of 4 microns of imprecision for this hole. The standard drill, our 2 flutes drill, has the double and a bit more from the competition drill. However, what you can see on the competition drill is that you barely see a triangle shape, and this is typically an effect of the 2 flutes drill. In comparison, our 353 series shows a really good linearity of this hole with a really precise circularity. Furthermore, you see as well that this circularity is really stable in the time. So we did with 1 drill more than 3,500 holes, and all this was really perfect. So between 2 and 5 microns of unprecision in the roundness. What I can show you now is the part that we make. So it's a titanium part with multiple holes. You barely see that. You saw it on the video, so but you can see that there is no burr, no on the top or on the bottom plates, and you barely see as well that the holes, the inner side of the hole is really shiny and mirror-like. This is a reason why this cutter is so widely used in various markets, and in Rebel 8, it's really a bestseller from our portfolio. Um, let's say that now that you have a solution for the drilling in titanium, I would like to open a second survey or second poll, asking you what are the other challenging operation you do have for titanium. Can you please let us know what are your most challenging um, operation? Is it the milling? Is it the engraving? Is it the threading? Um, we are curious to know more about it. If we come back to our tool, this drill has been manufactured, as said, by Louis Bellet for many years. However, talking about it with our customer, we have noticed that few of them are aware of this tremendous performance in titanium. That's why we do this seminar, and this is also why we produce uh, these drills in very large volumes. Um, we perfectly master the production of the production process, and we pay a particular attention to the top quality and extremely stable production process. So you are sure that you always do have the best product in your hand coming from us. It's general for our production, and it's also true for this kind of tool. Um, and talking more about the production steps we do have, you have to also know that the quality is really a key point for us, and our colleagues from the production controls visually, dimensionally every steps of the production. I will come back now on the presentation, showing you here a custom tool, because it's very important for us or for you to know that this drill can be customized, and it can be really specifically designed for your own needs. Should you need another shank diameter, dedicated drilling diameter with tight tolerances, should it be a step drill? We also can do through coolant, starting at 3 millimeters, so really free through coolant holes inside of the drill. We can really adapt the design to your most demanding needs. In the last survey, you told us where the other operation with which you had trouble with in titanium. The next poll would be for us to better know in which other material you do the machining. For your information, which other material you do machine in your production shop. You need to know, or you certainly know, that we do have expert tools dedicated from various material. Should it be stainless steel? Should it be composite? Should it be aluminum? You can find more information on our website, but you definitely can also contact me and email me if you need more information about this. We come now to the question and answer session. So don't hesitate to ask me some question. Let me see if we do have some. Yes. Does this tool perform well also in other materials? That's a good question. Actually, this tool is also working with different other materials. We used it, surprisingly, some of our customers did test it in various material like brass. We know that it's not meant to be used that much with stainless steel, but we know it works well with in platinum with a dedicated coating. So and also it's used for uh, um, you can drill and ream as a reamer. You can use it as well as a reamer because it's really precise, and the free lips, so the free flutes, really auto center the drill inside of the material. So if you pre-drill a bit smaller and have the 353 making the reaming, then it performs pretty well. I hope I answered that question. Is there another one? We have another one. Are we forced to deburr in the use of this drill? It's a good question. We do recommend to deburr each quarter of the diameter. It's better. It's better for the centering, for the life duration of the tool as well. We know that some customers don't deburr, but it's our recommendation to do so. Another one, maybe. Yes. Does it perform equally well in large diameters? Yes. So as said, we did the test with a 3 millimeter diameter. We went down to, of course, down to 0.1 or even lower, but grinding free flutes on dimension smaller than 0.1 millimeter, it becomes to be challenging. But answering the question, so perform is it as well really good in large diameter? Yes, as said. So this one is a 8 millimeter. Oops, I don't know if you can see it. Well, it's not perfect, but yeah, it's a 8 millimeter drill. We go up to 14 millimeters. We also did that with bigger diameters, and it was performing well. As I said as well, not this one, but another version of this tool has coolant through. So it allows you to have a better chip evacuation. And coming back to the previous question, maybe remove the deburring operation. That's an option as well, but of course not smaller than 3 millimeters diameter. Do we have other question? I don't see anymore. Maybe we can come back. You still can ask them if needed. But what I wanted to share with you are the polls or the surveys. The audience today did respond to the first question: in which industry are you working? Most of you are working on the automotive industry with 57%, other industry as well. And then aeronautic aerospace 43%, medtech 29%, and dental and watch industry 14%. The second poll was challenging operation in titanium. A really clear answer is about the milling. You might have some troubles with end milling in titanium. As said before, we do have expert tools for titanium, so don't hesitate to surf on our website or ask me, and I will be glad to point you the best tool for titanium milling. We do have a combination between geometry, carbide type, and coating, which is allowing our customer to really exceed what they were expecting in life duration of end mill. So yeah, don't hesitate to contact me. The other main operation are shape milling and threading with 25%. Engraving, cutting, and stamping are closing the march with 8%. The other material that you do machine in your production shop, we do have also a clear answer here in stainless steel with 91%. Maybe you did follow the last webinar. some weeks ago. That one you can find on our YouTube channel. It was presenting the 1620F, our super finishing end milling. So should you have any interest in end milling stainless steel, we do have the standard version 1620 and the super finishing version 1620F. It's a variable helix end mill. So please go ahead and have a look on a video to know more about this tool. Aluminum and steel with 73 and 64%, non-ferrous material with 55%, composite 36, and precious metals with 18%. We come to the end of this webinar dedicated to our 353 drill series for titanium. I hope it gave you the answer to your question. You will shortly receive an email with a technical brochure and summarizing the information that was presented to you during this session. Shouldn't you have all the answer to your question, or should you have further information that you might need to know, then directly contact me or info@Louis Bellet, and we'll be glad to answer them really quickly. I would more than recommend you to follow us on our different communication channels like LinkedIn, our website, lbsa.ch, or as mentioned before, our YouTube channel, on which this seminar as well will be put within some days or some weeks, let's say. The next webinar will be dedicated to hub operation, more specifically on our duplex solution, which allows you to have a burr-free hub cutting. So stay tuned, and in these days, stay healthy as well. So I thank you once more being here today, tonight, or this morning, depending on where you are. Have a great day. Take care, and good machining with Louis Bellet tools. Thank you very much.